Okay, so these trig functions you will have to memorize, but it's not a lot. It's 8, but technically these are inverses of each other. So you just technically have to know the 4 top ones and just take the reciprocal of the other ones. So if you notice, they're just the opposite of each other for the test. We're going to be using these on the next question to solve. So for this problem, they're saying that we need to rewrite this as a tangent, so something like this. We know that tangent is sine over cosine, so if I change these to all be sines and cosines, I could probably make something that it's going to be a tangent. And I'm going to be using the trig identities from the identities from the beginning, from the last slide. So we already have a sine here, so we're just going to keep that sine. And we know that cosecant is the same thing as 1 over cosine. So this is going to be 1 over cosine squared x, because if secant is squared, then cosine squared. And we know that secant is the same thing as 1 over sine. And that one doesn't have a square, so it's just going to stay as a regular sine. The next thing we're going to do is we're going to simplify the top part. And this is a numerator, so just multiply times that. And then we're going to have sine over cosine squared x. All of that divided by 1 over sine of x. And then what you're going to do is you're going to keep this, change it to multiplication, and flip it. So keep, change, flip. And we're going to have sine, I forgot the x there, of x over cosine squared of x. Change it to multiplication and flip it over 1. And now you're going to get sine squared x over cosine squared x. And we know that sine over cosine is tangent, so this means this is going to be tangent squared x. So that's your answer. For this problem, they want us to write it as just a secant. So we know that cosecant, honestly, it's easier if you write everything in sines and cosines. It just makes it easier to simplify and cancel things out. Cosecant, we know it's the same thing as 1 over sine of x. And we know that tangent is the same thing as sine of x over cosine of x. And then this in the numerator reduces with this in the denominator. So now you have 1 over cosine of x. And 1 over cosine of x is 1 over secant of x. So now I wrote everything as a secant, so that's my answer. Oh, wait, no, sorry. It's just secant, not over secant. It's secant of x. These Pythagorean identities, you don't have to memorize, but I want you to understand that these are interchangeable. So I could rewrite sine squared theta cosine squared theta equals 1 as cosine squared theta 1 minus sine, just by subtracting the sine over. And the same thing for, I can write it as sine squared equals 1 minus cosine by subtracting the cosine on the other side. And you can do the same thing for these. So each of these Pythagorean identities are equivalent forms, and we could add or subtract these around to manipulate them. And then we could use them to find or simplify or change the ways other identities look like, because they're equivalent. You do not need to memorize these. I will put them on the board during the test. These you do not have to memorize. I'm not even going to put on the test, but these are the inverse trigonometric identities. I'm not going to put them on the test, but I just want to give them to you. So on this question, they want you to write tangent of x divided by cosecant of x just as cosine. So again, remember I said it's easier if you write everything in sines and cosines. So I'm going to write the tangent as sine of x over cosine of x. And then we know that cosecant is the same thing as 1 over sine of x. And then we're just going to keep change flip. So we have sine of x. I forgot to put an x there. Over cosine of x. Change that to multiplication. Flip it. And then we just multiply across. So we have 2 sines. So that's squared over cosine of x. And then we know that sine squared x is equal to, from our Pythagorean identities, we know that that's the same thing as 1 minus cosine squared of x. So this piece basically is going to be substituted in there. So now we have 1 minus cosine squared of x over cosine. This is why we use manipulation, and that's my answer. Because we just substituting the values, because we know that sine squared of x is equal to that from our Pythagorean identities.